y'all have already done direct variation. Does that word sound familiar, or that phrase sound familiar to anyone? Raise your hand if it sounds familiar. Okay. So y'all did learn about it. Maybe you just didn't hear the terms of direct variation, but a linear relationship is called direct variation when the ratio of the y-coordinate to the x-coordinate is constant. Okay, and then a phrase that we're going to hear a lot of is y varies directly with x. That is going to be in a lot of our problems. We'll see it later on in class. But for direct variation, you guys have done it before. Maybe you just haven't heard that it was called direct variation. You might have heard that graphs were proportional versus not proportional.
Yeah.
It's the same thing. If it's proportional, what did it have to go through? It's a line that goes through what? It goes through the origin. Or the y-intercept is always going to be 0, 0. There was also an equation, I think, that you've seen before. Y equals kx. Does that look familiar?
No.
No? I hope to some people it looks familiar. Maybe it was just y equals mx.
I remember the K. No, it wasn't. Maybe I did not. So.
Okay. So the K stands for your constant ratio. So what it's talking about the y to x coordinates. So what we're going to be doing a lot of is writing equations for direct variation. Well, if you're writing equations for direct variation, all you need to plug in is something for K. Think about what we've been doing. If I want to solve for K, how would I write that equation, but with K by itself?
K equals y
divided by x.
K equals y over x. So that is our ratio, y over x. We're going to be doing that a lot today. But the two main things, it's direct variation if it is linear and goes through the origin. That's our two requirements. So if it's graphs are real easy. Is it a straight line and is it going through the origin? Pretty easy to see it if it's straight and if it's going through the origin. Mm-hmm. And then for pointer table, we have to find the ratio of y over x. If it has a constant ratio, so the y over x is the same as the slope, then we have direct variation. The direct variation constant, so that ratio, it's another word for slope. It's still your slope. It's just that whenever you have a graph that goes to the origin, you can call it more than just your slope. It's called your ratio, it's called your constant rate of change, it's your constant of proportionality, but all of those are saying the same thing. So let's practice some of those problems. On that first one, the graphs are my favorite because I think they're the easiest ones, but maybe it might be different. Graph, is that a straight line?
Yes.
Because it goes to the origin.
Yes.
Okay, then it's direct variation. So, to write the equation for direct variation is y equals kx. We need to plug in a number for k, and that is it. The k equation that we just talked about, if you got k by itself, k is really a y over x.
So it's like rise over run?
It is essentially, but it's even easier because since it goes to the origin, we don't even need to count rise over run. Just find a point. We need 1 point. Which is other than the origin, sorry. Other than the origin. So if we take this point, which is 215, since it goes through the origin, our k value, 15 over 2. Yes. Okay, so plugging in for our equation, y equals 15 halves x, and that's it. We've got direct variation.
That's how much you did then.
Well, it's the same as slope-intercept form, it's just that the y-intercept is what?
0.
0, so there's nothing after it. So then on the second one, we have 2 points. to see if it's direct variation. It needs to be a straight line, it needs to go through the origin. What we can do if we have 2 points, what's something we'll need to figure out?
Y-intercept. No.
Change in Y.
Okay.
Change in Y.
So the slope, if we get the slope, so 9 minus 6 over -3 minus -2, that's 3, that becomes a plus over -1, so -3.
And then you just pick a point and then do the.
There you
and then
go.
see if it's-
See there.
It goes to the origin.
Okay. We got a few options here. So one of the options, I'll start with Sean, what you were saying. One of the options, if we figure out it goes to the origin, so if we figure out what the y-intercept is, which we were saying, take the number we just got and plug it in for m, pick one of the points. Which point do you like better?
You know, I like the bigger one.
Yeah.
Plug in for y x, so 6 equals -3 times -2.
Where there is
Plus
no
B.
such thing as bigger points.
Okay.
I mean the highest one.
So then 6 equals 6 plus b. So what's the y-intercept? Y-intercept 0. Okay, so did it go through the origin?
Yes.
Wonderful. Since it went through the origin, that means this is direct variation. And our equation, we can write it as y equals
-3x.
-3x, because our slope is the same as that ratio. That was option 1. Option 2, the thing with direct variation, if the slope matches with the ratios of y over x, so take each point, 9 over -3, what does this equal?
That equals
Negative
negative.
-3. And then if we did it with the other point, 6 over -2, what does that equal?
Negative.
Since all 3 of these things matched, that is another way to know that was direct variation.
I do not understand how does that work, but that's magical.
Then the last way, what we've done before, we have -3, 9 is an ordered pair, -2, 6 is an ordered pair. Could you keep going to find if it fit in there? So this is -3. So subtract 3 again, this would be a 3, and this would be a 0. So again, 3 different ways to check to see if it goes to the origin. Any 3 that you like, choose that way. Alright, then the last one. For a table. Nice thing, what is that table showing you? What's it showing you? It's showing you that it's going through the origin, so that part's good. So the other thing we need to check all of the ratios y over x. So 3 over 6, 5 over 10, and then 8 over 16. If they are all the same, then it's direct variation. Are they all the same?
Yes.
What are they all equal? They're all 1/2. Since they all equal 1/2, that is direct variation. Okay, so on the next page, we're starting with those, or we're still using those two, y equals kx, or if we're just trying to get the k value, y equals, or x, geez, k equals y over x. So on the first one, if y varies directly with x, see it's that phrase that popped up again? It is always going to be that y varies directly with x. Write a direct variation equation for when y equals 10 and x equals 3. So to write the equation, we just need the k value. K is y over x. So what would that fraction be? 10 over 3. So our equation, y equals 10/3 x. Then for the next one, it's the same phrase. If A varies directly with B, it's the same as before though. It's always that y varies directly with x. So for our problem, A, anytime we see A, that is really all of our y values. And anytime we see B, that's really all of our x values. So it's just switching out the letters. It's always that same order though, that y varies directly with x.
Why?
So for k, it's usually supposed to be y over x, but in this case, it would be a over b, which means, what would the fraction be? 1 over 7. So for our equation, y equals 1/7. Oops, not y and not x. It would be a equals 1/7 b. Okay. Then for the last one, it's the same beginning phrase. This phrase will pop up a lot. N varies directly with n. It's always that y varies directly with x. So as you go through the problem, anytime we see an m, that's really our y values, and anytime we see an n, that's really our x values. So when it comes to finding k, if it's y over x, for this problem, it'll be m over n. So 6 over 2, which is really 3. So for our equation, m equals 3n. That's part 1. Part 2, find n when m equals 12. So if m is 12, plug in 12 for m. What's the n value now? 4.
Sure.
On the next part, we're not going to do this middle part, actually. Okay, so the weight of y of an object on Titan, one of Saturn's moons, is proportional to the weight x of an object on Earth. The object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. So it's saying that they have this proportional weight, meaning their weights vary directly. So the weight Earth, what did they say the weight Earth was? 105, and the Titan Earth is 15. They said also that x is your Earth weight and y is your Titan weight. So to get your k value, it's always y over x. So what would it be for this one? 15 over 105, and that can simplify to be 1/7, which means we found the k value, which means when it wants you to write an equation, we're done. Y equals 1/7 x. Okay. I want y'all to try the bottom ones. So go ahead and do the same thing. Y varies directly with x. So when it comes to getting your k value, it's distance over time. So 280 over the 5.5. What y'all get when you round that?
50 points.
51.9.
If we have about 50.9, if you round it with 51, your answer should still be relatively close to whatever we should all have close answers.
300.
Okay, so there's your equation. And then to get your answer for the 7 hours,
You would multiply maybe that by 7.
yep, which is approximately how many miles?
355.
Yeah, 3.6 or something. So I'm gonna make it about.
0.364.
Wait, but I thought you are like.
0.36.
Wait,
That's gonna be a 0.54.
Wait.
So for the tables, on that first one, okay. So for those tables, if it's direct variation, if the ratios are constant and it's going through the order. So on this first one, if we do our ratios, so 3 over 15, 1 over 5, 5 over 25, and then 10 over 50.
Yeah.
Do those all equal the same thing?
Exactly.
What do they all equal?
1/5.
Okay, so if it is direct variation, then it's going to be the k value has 1/5. If we put the origin inside the table, because it's not there right now, if we put it in there, and the way to get to the origin still matches with that 1/5, then we're good. That means it's direct variation. Or that origin fits. How do you get from 10 to 0? Minus 10?
Minus 2.
And then minus 50. So that means this would be negative 10 over negative 50. Does that still match with 1/5?
Yes.
And since it does, that means the origin fit nicely with the rest of it with that constant ratio. So this is direct variation. And the equation would be y equals 1/5 x. Now for the second one. It shows the origin, so that part's good. But we also need to check, are all the rates constant? Are all the ratios constant? So y over x, negative 8 over negative 2, 16 over 4, and then 32 over negative 8.
No, it's undefined.
Because you can't do the negative.
Oh, it's undefined.
Do they all match?
Oh.
4, 4, negative, and negative 4. That means that is not direct variation because it doesn't fit. Okay, so something that's not on your notes page, but this is something that's on your review. How to tell from an equation if you have direct variation or not. That direct variation equation is y equals kx, right? So what part's missing?
Okay.
Well, when we have it, we usually have y equals mx plus b, right? That's our usual equations. What's different? The y-intercept has to be 0. So there needs to be nothing at the end. How could I check from this first equation if it was direct variation or not? Yes.
Wait, what was the question again?
It would make sense because there's
Okay.
addition.
If we subtract 3x,
Then it's
but that would be 2y equals negative 3x plus 4.
It's not supposed to be plus 4.
So what's not supposed to be there?
The addition plus 4.
Okay.
Oh.
So this part is making it not direct variation. I know what you're trying to say. That part is making it not direct variation. So this one would be a no. I'm going to tell you right now, this one is also a no.
Yeah, that one's also a no.
This is a no. This is a yes.
Oh my god.
How can you tell?
Oh my god. The end is not zero. Oh my god.
If you ever have a term that is a constant, so something without a letter attached to it. How there's a 4 here, how there's a 15 here, how there's a 10 here. That would end up being your y-intercept when you got it into slope-intercept form. Meaning you're going to have a y-intercept that's not 0.